Okay, hi everyone. Though this webinar is being recorded, we can't see or hear any of you guys that have registered, but you, of course, can see or hear us. I'll start by making introductions. So my name's Adam, and I'm Manager for Student Recruitment and Admissions at the College of Engineering at Swansea University. We're joined by Annabel. So you can tell us a little bit about yourself, Annabel.
Hiya, I'm Annabel. I am a third-year medical engineering student.
Fantastic. We've got Dr. Sanjeev Sharma.
Hello, I'm a senior lecturer in medical engineering, and I coordinate courses on research projects and principles in nanomedicine.
Fantastic. And we've got Dr. Harry Arora.
Hi, I'm also a senior lecturer in medical engineering, and I'm also the admissions tutor.
Great. So the way that this is going to work is I'm going to hand over to Harry shortly, and he's going to present an overview of our medical engineering program. At any time during the presentation, you can type in any questions that you've got. So on your display screen, you'll see the Q&A panel button. You can type in your questions, and then following the presentation, Annabel, Sanjeev, Harry and I will then answer as many of those questions as we can get through them. Okay? So without further ado then, I'll hand over to Harry, if you want to share your screen.
Yeah.
That's good.
Right. Hello everyone, so glad you can join. So today I'm going to give an overview of what you can expect from medical engineering here, particularly at Swansea, and also the kinds of skills that you could end up developing throughout your time here and where they could be applied and future career pathways. So I'm sure you've got a fair idea of what medical engineering is, but I'd like to differentiate what you can expect from medical engineering here compared to potentially elsewhere. So essentially, we're applying engineering principles to medical or biological applications. Now, where we sort of differ to other places, we give a broad coverage to each of the disciplines here in medical engineering. So this is highly interdisciplinary. We're not just medical applications to a mechanical engineering degree or an electrical engineering degree. We give focus to each of these areas, so mechanical, electronics, materials, chemistry, and strong mathematical components. So we give you that broad foundation so that you have that opportunity to specialize in the areas which suit you. So it's quite early to be making choices on what degree to do to start off with, but also in terms of medical engineering, because it's such a broad, highly adapting area, we feel it's important to give you that broad foundation, to give you the opportunity to specialize as you wish after your studies here. So in terms of what you can expect, well, in the first year, you'll have subjects which you would see in any one of these disciplines, whether it's mechanical, electrical, materials, etc. So this gives you that introductory information, all of the sort of language you need to speak each of these individual disciplines. You'll be taught by experts in these areas. And then after you've got that initial overload of information, that's when you'll be taught by medical specific lecturers. So people on the medical engineering portfolio who will give you further knowledge in these different discipline areas, but specific to medical. So for instance, I teach a mathematics module in second year, and although it's highly mathematical as the subject you can expect, the idea is that it bridges gaps in certain modules which you're doing towards the later end of your second year and third year, which is specific to medical engineering. So for instance, how to handle multiple variables. Say for instance, you're looking at how nutrients get into cells from the bloodstream. You need to know something about fluids, you need to know something about mass transfer, you need to know something about the biochemical processes that can happen. And so having these tools to allow you to handle multiple variables is something which we do, but we're tailoring this towards the medical side. And there's lots of different subjects which we can have examples like that. But as you go through from first year, so you have that general foundation, we start to specialize and specialize as you go through in each of these areas. So you might have this already certain subjects in mind about when you chose medical engineering, such as tissue engineering or prosthetics. These are very big areas which I'm sure you've read a lot about. But before you go into these areas, so say if you're more of a mechanical person, materials person, like a bit of design, towards your third year, you'll go into subjects like prosthetics or medical implants. If you're more into the sort of biochemical side and mechanics side, then maybe things like tissue engineering make more sense. But again, we're giving you that opportunity to learn what these subjects all offer in each of these areas, so that you can make a more informed choice without being highly specialized when you start from year one. So this way you get to see what it's all about and make a more informed choice when you go into your specialties and potentially a specialized career. So that's how we kind of structure things, and we can go into more details in questions later. So other things which are special about studying here, from employers, things which they really like to see is the fact that we offer lots of opportunities for you to go work in industry or go study overseas. So for instance, we have this exchange program at Texas A&M, a very good engineering university as well. And so some of our top students can go and have an opportunity to study there for a term. And what this means is, from an employer's perspective, they'll say, you've gone to a new environment, you've adapted in a very short space of time, and you've thrived there. And so this shows your sort of maturity, your ability to learn new skills, all these sorts of things in a condensed period of time. And so this just enhances your learning skills and your maturity in the eyes of an employer. And it's not just those few who get to go there who will benefit from such schemes. Because we have this nice tight cohort of students, typically 30 to 40, when students go away to these programs and come back, they bring that experience with them. And so the students who have been working here in Swansea, apologies for the loud car if that's come through, people who've come back bring these experiences with them. And equally, the students who stayed here can share their experiences of what they've gained through the time whilst the others were away. And so we have that nice mixing. So as a cohort, as a group, you get to grow and gain from these experiences. So these are some of the other opportunities we can have. Other support which is important to highlight is the fact that although you're here to study, and you'll have people like myself and Sanjeev who will be there as academic mentors to help guide you and give you advice on the studying side. The step to university is not just about learning a new course, learning a new subject. There's a new way of living, and there's many things which should come along the way, which may potentially get in the way of your ability to work. And we have all of these really supportive teams around us who will help students get through these times and make sure you have everything you need to give you a fair chance to do the best you can with your studies. And that's the main thing. So I found that these sorts of teams, these support teams, are really, really good at making sure that students can keep on track, no matter if they come across points of difficulty in the time here. So you might be thinking, okay, I've covered all of these areas of science, engineering, gone into this medical applications. And although I've said that we're doing a nice broad coverage in terms of what the flavor of medical engineering is we're giving, you might still think, is this highly specialized? Am I committing too soon to the medical industry? Well, okay, let's break this down. First of all, the area of medical engineering is a massive area, and the industries are popping up all the time. Different companies are popping up all the time. We also have, we're part of a network called MediWales, which connects all medical engineering companies in the area of wells together. And so led also by Sanjeev here, who's our industrial liaison. We can facilitate these opportunities for you to find the job in the area of your interest. But also, as the portfolio, we're quite active in terms of each academic having their own industrial contacts. And again, because we have this nice tight cohort, 30 to 40 students, we have a lot of time to give you the opportunities if you take time to talk to us. So this is what we kind of encourage if you wanted to get into these types of jobs. But equally, because you have that broad foundation in engineering, you're not just tied to medical. You could be a very good engineer in other areas. So let's say at the end of the day, you go, I've enjoyed my time, I've learned a lot, and I liked working on these problems, but I still want to work on designing some windows in a civil engineering company or something like that. You can easily do this because you have those skills. And the reason why I'm confident in saying that is the fact that your degree will be accredited also by IMechE as well. So this means that any employer will see your degree in the same light, and they'll say, okay, you've got all of these skills, all of these things ticked. So therefore, you can easily go into one of these other more conventional jobs if you were concerned at this stage. But like I say, medical engineering is a major area, lots of innovations. So I assume you'll probably still want to go work in there, but just to put your mind at ease, you do have this to fall back on. So your opportunities are wide and open. And yes, so in terms of employability, the university does a lot more beyond what just medical engineering does to try and facilitate that and support you in your path to that. So the next sort of step, things that I'm going to go through are more related to the types of skills which you could develop in application areas you could go into. So there's lots of really fascinating and interesting projects kicking off here in Swansea. And actually, a lot of the time, they start off as third-year undergraduate projects. So after your first 2 years, you would have gained all of this general knowledge in these different areas. You'd have gained some practical skills. And then you can go off and start to apply them, have your own ideas, and develop them in our labs. And so I'm going to go through a few different subject areas and just to highlight the types of skills you might be using in these areas. So for instance, we have sort of diagnostics and sensor development. Again, if you are keen sort of electrical engineer, you like a bit of that biochemistry, this is a sort of area you can go into, developing the next generation types of sensors and things like this. So nanotechnology, another sort of big area which you might have heard of, not just in developing the sorts of devices or looking at the interfacing. I like to highlight things like lab on a chip here because it kind of embodies what a medical engineer could do. So not sure if you've heard of this, but essentially, conventionally, if someone was say to develop a sort of drug, what they might do, they might go through a series of tests doing some cell culture. They might then go into animal studies, and then they'll go into clinical trials and things like this. What we could do is, if we know something about the physiology, if we know something about the local mechanics, the local environment, we can replicate that in a synthetic platform. And that's what this lab on a chip is. So let's say we wanted to simulate the lung. We can have this little device which stretches and deforms like a bit of epithelial lining of your lung would do. We can pass through various fluids and we can screen a certain drug. We can do this hundreds of times on hundreds of chips very efficiently. So you can have a high throughput, but also more ethical option compared to necessarily hundreds of animal experiments. And so this is sorts of innovations that a medical engineer can develop to advance and speed up the sort of processes of developing the next sort of treatments and interventions. Now, medical imaging, this was one of the areas which got me into medical engineering. And this is because of the way in which you can look at things on multiple scales from the cell to whole body, but also not just looking at structural elements, you're looking at, you can tag the cells, sort of the biochemical aspects as well, to get a dynamic view of how the structure is adapting and changing to a certain stimulus or problem. And so this is one of the areas where you can go from not only just having a sort of structural snapshot, you can have dynamic images, and then moving towards things like patient-specific modeling. So on that subject, actually, those of you familiar with sort of computational methods, finite element method, Swansea University is actually one of the world leaders in this area. It's the home of finite element method. This is where it was all developed. So if these are the sorts of skills you're looking for, this is certainly the best place to be learning it. So going on to what we're thinking in terms of patient-specific modeling, we're actually developing models now where you can have a complete replica of, say, someone's cardiovascular system, and we can have data being fed in from a patient live from their bedside, and we can be simulating when that patient is potentially at risk and may need a certain treatment, certain intervention. So we can help to optimize the nature and the timing of certain interventions to help that person. And actually in our group led by Professor Nitharasu, we've been adapting his models for pneumonia to actually start to study what's happening in this current crisis. So we're actually having live feedback to be able to predict how and when someone potentially might need further assistance with their breathing and when they may need to be taken off if they've recovered. So these are things which we're starting to adapt now, and this is what we can do in the power of sort of digital technology. A final sort of example, looking at the fact that we have a nice sports science department as well next door. We get lots of data from their work in various activities, but also things like trauma, developing again sensors to allow us to not just to monitor, but also the fact that you're an engineer, you can handle big data, you can handle all of these different data sets and try and create models to try and understand what's happening in these complex dynamic systems. So this is where that sort of interaction comes in and where you play a big role as a medical engineer. Finally, onto something which is very interesting on microneedles, where, okay, I've mentioned a lot of things about diagnostics. Well, how useful is it? Is it, okay, we can diagnose something and then you say, okay, there's a problem, you have to go to the doctor, then you get your treatment. There's this delay, there's this lag. Whereas if you, say, had a device like this, where you can not only diagnose, but also deliver the therapy at the same time to the correct dose, then you cut out that lag. And so you can have a more optimized way of treating things. And this is one of the projects led by Dr. Sharma as well. So I've mentioned all of these projects, and actually you as an undergrad will be going into these areas. You'll be working with these people on these projects as part of your third year. After your first couple of years, you'd have got sufficient skills to step into any of these projects. But now I just wanted to say, why is it so important I've mentioned all of these sorts of topics? Well, all of the staff, most of the staff on our portfolio are highly research active. And in each of these areas, which cover all of the disciplines which you would be studying, it's important to keep up to date with the latest tech and the latest advances in these areas. Because medical engineering, like I said, is a constantly evolving, constant innovations going on, we need to keep up to date. And so having staff who are research active is a benefit in the fact that we can maintain the technical skills, which is important and relevant to the current technology. And so this is what we're constantly doing. So I just want to flag one more project. So I do a lot of work looking at different X-ray imaging, and one of our second years last year came along with me to Diamond Light Source. So this is a synchrotron facility, national facility in Oxfordshire. So she took my maths course and said, oh, we can use this maths to analyze medical images. I said, yeah. And then I created an opportunity to have a 4-week paid placement. And she came along and started to work on these medical images. So we're studying lungs, and by the end of the 4 weeks, she was able to produce images such as these, where here you're looking at the smallest airways in the lung. So these are the alveoli, these are the little air spaces which allow us to breathe. Now the color contour map here is just indicative of the local thickness variation of the tissue around those airways. And what this allows us to do is to say, well, if the structure is changing in this sort of way, how does the local mechanics change? And if in injury, illness, or disease, how does that impact the local breathing mechanics, but then also the global mechanics, which we can measure in a clinic? And actually, a lot of this work has been going into, is also being adapted to help us with the current crisis as well. And so one part of it is the fact that we had to develop a lot of nice devices. I'm just showing a quick little overview of things. So including this ventilator, which now is being adapted by my collaborators at Imperial College London to scale up for this current lack of ventilators. But here was the prototype I built to analyze small lung segments. And the reason why I wanted to show this is that, again, this is another example which encompasses what a medical engineer can deliver by the end of their degree. So first of all, we're trying to image lungs. So we need to know something about the physiology. We need to know something about the local tissue behavior, the mechanical behavior, but also the fluid mechanics, the dynamics of the air moving in and out of the airways. And then we need to create a system to pump things. So we're going to be working with air, compressible gas. There's going to be all of this sort of movement of the gas, compression. We need to account for these compliances in the system. So good knowledge of fluid mechanics will allow us to calculate this to create a suitable pumping device. Then mechanical engineering side of me had to come up with a way of putting this into a nice housing, designing that all appropriately. We're now integrating sensors to monitor pressure. We're using solenoid valves to not pop the lungs and things like this. So all of this needs some good knowledge of electronics to wire it all together. And then there's the coding side. We need to control the pump in a suitable way so that we can inflate and deflate our lung accordingly. And so bringing all this together, after your time as a medical engineer, you could walk into a project like this and take it from start to finish. And so this is why I wanted to highlight this sort of project to you, because it allows us to do really complex, multidisciplinary things, but just as an individual engineer there, although I do work in bigger teams. And just while it's on topic, what that sort of device allowed us to do was to study. So this is a little image of some lung tissue again, and the color contours are showing the stretch in the airways. So the light regions are showing bits which are stretching. And again, we're able to take these dynamic images so that we can say, if someone had a poorly lung, say they're not behaving as they should, there could be things which could be overstretching and damaging them. And so one thing you might have heard of recently in terms of people going on ventilators is the potential for ventilator-induced lung injury. And this was some work which we'd done previously with one of my old undergraduates. But now we're sort of adapting this to try and say, well, how can we predict the sort of mechanical integrity of other sorts of inflamed types of lungs like we're having with the COVID crisis. So that was a lot on research, but also to say we do have some really good top experts on the teaching pathway. And so what this means is that life in university has changed, and the fact that we're working in a highly interdisciplinary course, a straightforward lecture might not always be the most efficient way of getting the information across. And we need to adapt to that. And so by having experts, including the person voted top lecturer here at Swansea, who teaches second year design, having all of that together means the fact that we can gain best practice from them. Me as a researcher can inform on the most up-to-date content, and we can get this good, nice balance of having the most efficient way to adapt our teaching practice. And this is continuously occurring to try and improve the way in which we teach. And so we have that nice balance in that, on that side of things. I think I've probably spoken enough. So that concludes all I wanted to say. All right.
Yeah, cool. If you just stop sharing your screen then, and then we'll have a gallery view for question and answer. Cool. Right, thanks very much, Harry. As I mentioned to any of the attendees, if you've got any questions now, you can type them into that Q&A display button, and we'll then answer them. I want to pick on something that you mentioned towards the beginning of it, Harry. I imagine most of the offer holders that we have online now are studying maths, but then it'd be variable backgrounds in physics, chemistry and biology, and to what degree people are studying that. So if a student hasn't studied maybe chemistry or physics, what does it mean then on entry in year one?
Well, what we look for is maths to start off with. So if that's missing, that's a problem for coming into year one at least. And then we look for strength in another science. And so we don't discriminate between the sciences when it comes to that second subject. The first one we look at is maths, and then we look for another science, because people will come in from the different areas.
If I'm coming in without physics though, do I need to be worried? And maybe Annabel, you can answer this as well, based on your first year experience. So if I haven't done chemistry or physics, should I be worried going into year one? And how are those sciences delivered to help everyone in year one then?
I didn't do chemistry at A-level, so I came in without that one. And it meant that in my first year, I had a choice between doing a foundation chemistry module or doing a, what was the other one? It was something more mechanical engineering wise. And because I hadn't got that foundation, I ended up doing the foundation chemistry, which caught me up on the bits from A-level that I needed to know, and meant that by the end of that first semester, I was at the same point as everyone else.
Brilliant. So there's ways to get people in and teach the fundamentals that wouldn't have been covered at A-level for those sciences. And
just to add to that, in terms of if you do have a worry about this, and I had my first year mentee who had not necessarily the complete set of modules from their maths when they studied it. So for instance, if you speak to your mentee, your tutor, then they can put you in touch to get top up as well. So if, say, this foundation course wasn't available in the particular subject you were interested in, there certainly would be modules from which can tag in from the foundation year, for instance, to catch people up if they weren't that confident. So there's always that opportunity to have that discussion, because again, we're a relatively small cohort, so we can be a bit more flexible like that.
I think as an add-on then, Sarah, one of the attendees has asked, if you've got physics, mechanics and chemistry at A-level, what options are there to choose in first year and maybe beyond that?
Well, so we don't offer choices, just saying that. So in terms of what you're going to be taking, you'll be taking all of it, because if you're making choices at this early stage, then you're not going to be able to necessarily take advantage of something which you would prefer in third year. So we tend to not offer any choices, so that those options remain for you. But where you can specialize is in your add-ons, your projects, and the things like that. So that's where you can go talk to those specific subject leads.
I think that's the key point, isn't it? We've got a very varied curriculum. There's a little bit of everything that the students will sample across, and then choose to specialise in projects, design projects, placement, internship, for example. Then. Yeah. Annabel, then, talking about that year one transition as well, then, how did you find that progression to go from A-levels into year one of medical engineering? What were the sort of challenges and maybe what was easy for you?
So I'd had a year out in between as well. So I was coming back into studies after having a year of working, which was quite different because I obviously felt like I'd forgotten half of what I'd learned at A-level. So coming into it, I was slightly concerned that I would be behind other people, that I would have forgotten my maths or whatever it was. But I found the course starts relatively gently. I think you pick it up very, very quickly. The lecturers are very good at making sure that everyone's on the same page and everyone's able to keep up with the workload, and that they are being fully supported wherever they're coming from. So I found that although I was not sure how it would go, it was fine. I found that it came back to me a lot quicker than I expected it to. and that new things that I hadn't done before were taught in a way that meant I was able to pick it up and be on the same page as everybody else.
Good. And how is year one in particular delivered? So like how many hours per week would you do? How many of them are big lectures or in a lab or a workshop, for example? Can you remember?
You're testing my memory now. Yes, I think I can remember most of it. You'll have to correct me if I get any facts wrong here, Harry. So we did 6 modules per semester. One of those 6 modules was always just the medical engineers. So it was on a much smaller scale. That's when you've got sort of 30-ish in your class. A lot of the other ones you're paired with different disciplines. So for some of them you might be paired with sports science in first year, which sort of doubles your course numbers. With others you might be with the mechanical engineers or the chemical engineers, which means you're looking at more lecture theatres of about 200, 250 people. So there's a lot of variety within that sort of thing. We did have lab work as well. I think that was in first year. We definitely had lab work as it went on, which was often done as medical engineers. So that was a lot more working in very small groups or in pairs and things like that to balance that side of things as well.
And then Kushbu has asked, how much harder is second year compared to first year? So rather than terming it as harder, how does the dynamic change and how does it differ as you move through your years then?
I think you do get an awareness that your second year results are weighted for your final degree, for your final score, rather than your first year results, which aren't. So I think people do have that sort of awareness, which means that they put some extra work in. They might put some extra focus on to the actual results that they're getting, as well as the process of learning it. I did the first semester on the exchange programme, so I wasn't in Swansea to have that comparison. I don't think the content jumps up a huge amount in terms of the difficulty in it. I think you do need to put more effort in, as you would be expected to do as you go through. And I think you do have to reflect that with the workload that you're putting in. But it's definitely manageable. I wouldn't say it's a huge jump up from one year to the next.
Okay, good.
Yeah, just to comment on that then. The fact that we have first year, like you said, with lots of different disciplines, you're basically getting that foundation knowledge, which perhaps isn't the most challenging. But the reason why there's potentially a perceived step up in second year is the fact that it does build up quickly, and so that's why I think potentially everywhere you study, the second year is always perceived as potentially more difficult. But that's the thing. So if there was something troubling in first year, you've got that time to correct it, and you've still got links to your previous work. And so this is something I particularly with the maths module. If there's 1 or 2 people struggling, I refer back to the first year modules and say, here's where the problems lie. So it's easy to pinpoint that and to go back and correct it. But that's potentially where that question comes from as well.
I think year 2 and even year 3 would seem daunting and scary right now before you even enter year 1, but like you said, it's much less daunting as you get into the flow of year 1 and you sort of pick up not just the knowledge stuff, but how university works, isn't it, and what the teachers are like and how exams and assessment work.
Yeah.
So on that, and I wonder, Sanjeev, if you could chip in a little bit here, because I know you're involved with the projects.
Yes, so I basically, the 2 things I could speak about. One is the employability. I'm also the employability champion for medical engineering. So I kind of get involved in these boot camps that are organized by the Swansea Employability Academy, wherein we get the students to prepare their CVs. We get them ready for interviews. We get them ready to kind of, spend that 1 year in industry and, how to get ready for that process. So that's one place where I kind of contribute, and the other place where I kind of I'm involved is doing research projects. These are mainly for research projects for students in year 3 and year 4. And what we do here is basically, Harry already mentioned, he's shown the fantastic fundamental research we have in the College of Engineering, in the medical engineering portfolio. So we actually give our students first-hand experience of working in a lab. We've got this fantastic facilities in a place called the Center for Nano Health, which is in the Singleton campus, where we have a mix of, it's basically a hotspot wherein you have the medics, engineers, everybody coming and working together. So that center is the Center for Nano Health, is where you get wonderful exposure. You get to work with the medics, you get to work with the engineers, with the software developers, and all sorts of skills there, multidisciplinary skills. And then you can do a fantastic project, which is kind of, which will actually make a good impact. And I've actually had one of my students who did a fantastic job with her project and managed to publish a paper in an internationally peer-reviewed journal. So we kind of get them ready to kind of go into the real world once they've got their degrees.
Great. So with that union industry then in particular, because we've got a question from one of the attendees,
yeah,
who hasn't yet applied for the union industry option,
yeah,
but may like to. So what would the process for that be? And if you can tell us a little bit then about where sort of placements are available and how they can be successfully get awarded those placements?
I think the year in, so because we've got limited spaces for the year in industry, so you've got a bit of a selection process there. So it's always said to be as the top students, which in other words means students who've got top grades. I think Annabel, correct me if I'm right. I think it's a minimum first that you need to get through. No, is it?
It's 55% in each year that's needed.
Or maybe 2-1 or 2-1. That's a minimum requirement. But as I said, because we've got we've got the numbers, you've got small numbers there, so there's a bit of a competition there. But over the years, what has happened is the number of students who've been doing their year in industry, that number is going up. So I think the new batch will have more spots available. So the competition might slightly be easier. But I think, as Harry pointed out, I think a minimum 2-1 is what you need to be considered for this year in industry.
Yeah. And in terms of like going for it, it's an admin process. So if during year one you've decided, oh, actually I want to do the year in industry now, it's a bit of paperwork that needs to be signed. You're put onto that pathway, and as long as you're maintaining that 55% grade average, yeah, you are eligible to apply and interview for placements.
Yeah.
Great. And simply then, Harry, there's a question: what grades are needed to change onto an MEng degree? And maybe you could explain the difference between a BEng and an MEng.
Yeah, I mean, in terms of going for the MEng, we typically say you need to be on a 2-1 for that. And the only reason for that is the fact that when you go from, when you're taking that extra year, what you don't want to do is to be on that borderline where your grade could potentially go down at the end of it, because you want to leave with the best degree you can. So this is why the only sort of advice we give is if you're on a solid 2-1, go for it. If you're borderline, we'll have a discussion, but it's still your choice. And so we'll run through that process with you. The main sort of differences, again, I showed how you go from foundation engineering all the way to the more high-end applied areas, and there's just more specialized subjects as well beyond that. So just following those themes again, there's further specialism. So that's the main sort of difference. And in terms of the sort of project side, again, just the expectation of what you deliver goes up. So that's roughly what you sort of expect.
With the projects then, Sanjeev, can you give us some, I know Harry's gone through some of the research themes and topics we've got here. Are those projects that are available in the final year prescribed, or can a student who's got an interest in something that's maybe not on a list, are they able to work with a member of staff on that?
Oh, we've got both the options. So either it could be a project that has been listed by one of the research supervisors, or if during your course you've liked somebody's work, for example, people interact, and a lot of times I get a lot of requests wherein people want to work with Harry, a very popular lecturers there, and they want to say, I want to work in his area. So then we normally advise them to sit with the person you would like to work with and design a project for yourself, and then you can come and submit that project. We're very flexible with that. You can either have a choice of doing something that has been kind of described by a research supervisor, or you could design your own project sitting down with a research supervisor of your choice and submit that project. So pretty flexible.
Good.
Yeah.
And Annabel, what are you specialising in?
Sorry, myself?
Annabel.
My project is on 3D printing of biomaterials. So it's a design project, and it's looking at how to adapt a 3D printer to print biomaterials. So research-wise, that might be looking at printing skin grafts or different materials like that, and how you can. It's been on SolidWorks, so it's been a lot of CAD design, and it's that sort of thing. So yeah, I'm really enjoying it.
Oh, good. And I guess similar to what we were saying about backgrounds in sciences, you know, if someone coming in hasn't got any experience or background with CAD, for example, or any of the other programs that we use, like MATLAB, for example, you know, how are they delivered to help students who don't have that background? Because that's going to be nearly all of them, isn't it?
Yeah, I'll go for it.
Yeah. So, I mean, I'm now very much aware of what we call as cafeteria. So we organize cafeterias wherein we have a postgraduate student or a PhD student or a postdoc who would run a cafeteria, like a session, wherein you could acquire those skills. So that person so it could be a person specializing in CAD, for example, who could help you learn CAD. So we have these cafeterias which we organize during the term. And the various topics that we organize, these are vary from computer-aided designing, chemistry. Some people want it a bit more specialized, so they say we want to have a foundation course on, say, electrochemistry. So we get them to attend those lectures. So we basically got this nice arrangement in place called the cafeteria during the term time. That helps as well.
And Annabel, did you utilise any of the maths or CAD support cafes, or have you utilised the sort of career support teams at all in your time here?
Yeah, I've used the career support. So I did a year in industry last year. So I was part of the group who went through submitting their CV and doing a lot of tests on interview skills and doing employability days and things like that. So I very much utilised all of those, which meant that I was able to get a placement and now onto their grad scheme at the same company. So that I found that incredibly useful for that side of things, yeah.
Good. Got a question here I think I can answer. So already accepted into the B-Eng with a year in industry. Do they have to have the place in industry secured, or can it be left without that? So basically, like we said, we're flexible in people adding on the year in industry option if they want to go for that. If they're on the year in industry pathway and they choose they don't want to do it anymore, then again, that's easily an admin process which you could be removed. Being on the year in industry pathway isn't a guarantee that you're going to get that placement. You've got to go through the, you know, at times very rigorous selection process that any graduates would go through to be able to secure a placement. It is competitive. But as Annabel said, there's all of that support that would prepare you and simulate interviews in assessment centres, for example, so that you've got every chance to be successful to get that placement. Okay, there's a question for Sanjeev. Are projects mainly individual, or are there also group projects?
Well, Harry, correct me if I'm wrong. I think in first year, second year, the projects are group projects. So you kind of allow you to do your projects in a group where everybody's expected to contribute equally. But I think as you move to year 3, year 4, the final year, or the master's projects, they are mostly individual projects, because as I said, there you're choosing a project which has either been pre-written by a research supervisor, or you design your own project.
Yeah, so in terms of subject-specific courseworks and things like this, you might be given a short-term or longer-term project to deliver on that topic, and those tend to be in groups. But when it comes to the research side, like Sanjeev said, in your third and fourth year, they'll be more individual.
There's a question, Harry, that you can answer the first part, and then I want to jump on. So obviously, school and college has been disrupted for nearly everyone across the world, and yes, qualifications are going to be assessed differently, but students are missing out on actual learning in the traditional environment and sense. So is there anything that students can do to prepare in terms of maths, especially, like what type of maths is important in engineering mathematics that students could maybe brush up on in advance?
So perhaps Annabel can comment as well after this. But in terms of, so I appreciate this is a big problem But in terms of first year, you tend to get a lot of the content which perhaps was in the advanced, say you didn't do further maths, even these sorts of things get covered in your first year. So we want to get everyone up to speed. So if there were certain topics, even in your choice, if you'd completed it, that you hadn't fully done a certain specialist module, then if it's needed, it would have been covered in your first year anyway. So all I can say is that it would be worthwhile brushing up on some of these things from your core topic, but equally you will have that chance to catch up in first year, and just be aware that it's something you need to work on, because maths is embedded throughout the degree. So if you don't address it in your first year, then it will become a problem. But I'd say that don't stress too much about studying and burning out before term starts, because we want you fresh when you come in first year, to be able to learn everything and not just one subject. So that's my bit of advice.
That answers a bit of a question that Larry has just asked as well. Like, is there any books or papers to recommend reading before the course? So it's that balance. Like, we don't ask that anybody does any, preparation or prior reading before entry. It's you're not obliged to at all. And I think certainly in the current climate, people are under a lot of stress and pressure and a different way of living and working. There are more important things than getting your head stuck into books and worrying about things that you may need in university. I'd rather people just focus on themselves separate to that. But if you are interested in anything, and again, you may be, missing working and missing schoolwork, we're actually going to be releasing some of the Maths Cafe and the engineering analysis modules and work through stuff to offer holders. So you can keep your eye out for that. And in constant communication up to enrolment, we'll be providing lots of info about stuff you need to prepare. We may provide some reading lists, but again, the important thing is to not feel obliged to do that at all. There are more important things than working, especially in these challenging times.
Can I jump in?
Yeah.
Just to add, I think the important thing is to get excited about it. If you're finding yourself with time on your hands and you want to be reading stuff and you want to be preparing for the course, then find some articles that are really interesting. Find your passion within medical engineering and spend your time learning about that, I think, is the most important thing.
Yeah. And then there's a couple of questions. There's one: if the university does not start in September, will there be online classes for first year students, or will the start date be postponed? So to answer that, Kushbu, we're considering everything. So the university has got various boards at various levels where we are going through all types of scenarios, for most of which the factors are out of our control, and it's how we will react and mitigate to that, that we're preparing as much as we fully can. So there will be options available that we will use to react to whatever the situation is. Until you hear any different, we're in the mindset that it's going to be business as usual in September, where students will enroll to the mid-end of September, and it will be classes delivered in the traditional method, obviously now with more enhanced remote provision available as well, as all of our students now and our teachers are going to be a dab hand at delivering and learning remotely. But it's business as usual until we hear any different. But obviously things can change, but we will be prepared for all eventualities, and we're very confident of that. We've got just a couple of minutes left, so if anyone's got any last questions to come in. I want to finish by talking about admissions, because again, we've spoken about disruption to people being able to study and complete qualifications, and concerns maybe about what grades people may be getting. On any given year at Swansea University, we are very flexible and fair when it comes to admissions and entry. So even those grades that students would have been offered initially, we are flexible beyond that to a certain extent. So at the point of results, if you've just missed out on the grade you were offered, but are above the minimum threshold, for most cases, you will be accepted. If you've done exceptionally well in maths, but then you've got a really, really poor grade in history that has brought your overall grades down. Frankly, I don't care about history when it comes to medical engineering, and so you've got nothing to worry about there. We do factor in other circumstances, so your student profile, your personal statements, your references, and obviously mitigating circumstances. Now, right now, there are extreme mitigating circumstances for everyone. So even more so this year, we are going to be flexible and we are going to be fair when it does come to admissions, when people get their results and we receive them at the university. So please don't be concerned at this point. There's still a lot of unknown for you guys still in school and college, but we're very well aware of that. We're certainly understanding of it. And all I ask is that you trust the process that we've got you at Swansea University, because we ultimately want the same as you, and that's to get you into the course of your choice at the university of your choice. So we will apply flexibility and fairness because this is an extremely challenging time for all you guys and all of us here, Annabel, Harry and Sanjay, you know, we all know that and are experiencing different challenges ourselves when it comes to work, but we're adapting and we're doing well. So there's no more questions come in now, so I think we'll wrap things up there. Thank you everyone for joining. Thank you, Sanjay, for your time.
Thank you, my pleasure.
Thank you, Annabel.
You're welcome.
And thank you, Harry.
It's all right.
And to everyone else, please do stay in touch. If you've got any questions or concerns, I'm going to share my contact details on the screen in a second. The university will be reaching out to you and you receive not an annoying amount of emails, but there will be important information that is sent to you. So please do keep your eye out for that. And if you do want to contact me directly, then feel free to take a snapshot of what's on screen there in a second. You can email me or you can WhatsApp and you can contact any of us at the university as well. Okay, has that come up on screen yet?
No.
No.
Okay. You've all got my contact details from the registration email as well, so please do stay in touch. All right, thanks everyone.
Thank you.
Bye.